This lesson is 3.1.2 Product Life Cycle. In this lesson, we will explain that different engineering solutions can have significantly different impacts on individuals, society, and the natural world. We're also going to describe the life cycle of a product or service, and then we'll evaluate a solution to a complex real-world problem and identify the need for trade-offs to address a range of criteria and constraints, including environmental impacts. So, have you ever wondered how the components in your computer or smartphone or any other product that you use on a daily basis actually become finished products? An example of this would be the plastic case that surrounds your Chromebook. It's not mined from the earth, it doesn't naturally occur or grow in a tree. It actually begins as crude oil. So, how do we take that viscous, gooey substance, like oil, and turn it into a plastic shell for consumer electronics like your Chromebook? And then, after we figured out how to do that and we use it, what happens to that plastic case once we don't need it anymore? Maybe the Chromebook becomes out of date and we replace it, or it becomes damaged, but what happens to it after that? The reality is that all things have a beginning and an end. For consumer products, engineers refer to this as a product life cycle. The life cycle assessment is used to study a product life cycle from raw materials through production, the manufacturing, the packaging, the distribution, the use of end life treatment, and its disposal. So, because energy is generated and consumed during every step of the product life cycle, engineers have to carefully assess this flow of energy to further their understanding. And engineers use the findings of a life cycle assessment to understand the environmental impacts of designs at every stage, so they can implement improvements in recycling and waste reduction. Engineers also use the life cycle assessment to learn how the environment is impacted by a product and to what degree. So, this image that we see on this slide actually shows us all of the different methods and places that we have to analyze the impact of energy in the product life cycle. So, beginning up here at raw materials extraction, that is where we actually get the raw materials, whether it be wood or oil for plastic or metal that we mine from the earth. We have to look at how we gather those materials and how we do that sustainably or maybe not so sustainably. Then those materials have to be processed. We have to take them and use those manufacturing processes we studied previously and create the final material that we want. So that could be through subtractive processing, additive, rolling, cutting, shearing, welding, all of those things. But somehow it gets processed and treated to become an item that we can then use in manufacturing. So these manufacturing processes sometimes also involve stamping, rolling, molding, all of those things, and that requires energy. From there, we then package those goods to then be distributed to consumers. So, between the packaging, what we put it in to then get it to the store, whether it be by truck or train or plane, okay, we have to analyze the energy that is used in those phases. Then we have to look at how it's utilized, how the consumer uses it, and can it be reused? And if it can't be reused or after we're done utilizing it, how do we dispose of it or recycle it? Okay, and how does that impact the environment? Okay. Now, looking at the life cycle from a marketing perspective, the reality is that all products progress sequentially through 5 stages of existence. We start by developing the product, then we introduce it to the market. We look at the growth of the market share, so how quickly people want it. It then goes into a stage called maturity, where we look at the use of it, and then decline, where people don't want to use it anymore. So, to prepare for evolving product requirements over time, designers have to work to understand each of these stages. So they apply this by considering the life cycle of a product when planning and designing for the future. During the product design and development phase, they consider the stakeholders, so the people who will use it, and their needs, and the sustainability of the product. Then, during the product introduction, they study early adopters to iterate the product design. So they look at people who are kind of beta testing it and figure out what needs to be improved and what doesn't. Then, during the growth stage, they focus on improving product supply and performance, making the product better, making sure people can get their hands on it. Then during the maturity stage, they refine the product to maximize consumer retention, to keep people coming back and purchasing their product. Then during decline, they focus efforts on the transition to the next generation of products. So all of this leads us to documenting the life cycle of a product, which comes back to that life cycle assessment. Again, it can also be called a life cycle analysis and it has 3 general steps that determine the overall environmental impact of a product. The first step is called an inventory analysis. When we do an inventory analysis, we look at the inputs and the outputs of a product's energy and materials from each step of the life cycle and how and then we calculate them. Okay. The second step is the impact analysis. We take the values from the inventory analysis, so the calculations from step one, and we add them to the respect to represent the impact on the environment. Then the third step is an improvement analysis. It's used to determine the methods to reduce the product's impact on the environment. So let's take a look at each of these steps and how we accomplish them. So the first step is that inventory analysis. Okay. In this class, we're going to be providing you with a template to use to complete your inventory analysis. And after you open that template, the first step will always be to complete the header section on the template with your product name, your name, and the date. You'll then go through the raw material extraction, materials processing, manufacturing, packaging, and distribution areas of that sheet. Okay. In the raw material extraction, you'll list all of the materials, whether it's metal, plastic, fabric, that are in the product. And then you assign 1 point for each material. You then complete the materials processing by listing all the metals and plastics in your product again, because most materials need to be processed before being used in a product. So, for every material that needs to be processed, as in it's not naturally occurring from the earth, then we assign a point. Then we complete the manufacturing area by listing all the components or parts, such as a screw or a plastic latch of the product that have been manufactured, meaning again, not naturally occurring. And then we assign 1 point for each individual part. We then complete the packaging by determining how the product is packaged and select the option that corresponds to the product. Then we'll complete the distribution and transportation by thinking about when a product is completed, how it has to be distributed. Do we send it on a plane, on a train? Okay, and then we select the option for how the product is transported. Then there's two other sections, the utilization and disposal. And in the utilization, we identify all the products have a lifespan for how long they can be used effectively. So we have to look at the option for how long a consumer can reasonably use the product. Then we complete the disposal by selecting the option that describes what happens to the product at its end of its useful life. So here you'll see screenshots of your template. These are the headers that we discussed that you'll fill out. And then you have the different sections that we just referred to. In the raw material extraction, you put the raw materials, and you'll see there's points for each one. Eventually, we'll total these points. That will be in the impact analysis phase. Materials processing, those are the metals or plastics in the product. Manufacturing are your parts and pieces. In the packaging, you can mark that it has none if it's paper or cardboard, plastic and cardboard, styrofoam or rubber, or there's instruction sheets that are included separately. Distribution is, does it need to go by a plane or truck or a boat, or does it not have to go anywhere? In most cases, you're going to have transportation though. Then utilization. Can it be used once? Can be used for what we think is 5 years? Can be used for 10 years? And then disposal, do we have to throw it away? Can we recycle part of it? Or can the whole thing be recycled? After we've completed that, we then move into the impact analysis. For the impact analysis, we complete this after the inventory analysis. So we can't do this until we filled out each of the respective boxes. What we have to do is we then have to find the sum for each step. Now, if you didn't use every row in these tables, you don't count that point. Okay, so if we fill out 3 rows here, that would give us 3 in our total points category total. Then, after we filled out all of those boxes, we add all of them up to get our impact analysis point total over here. Then we move on to the improvement analysis. Okay, now this is using your template, but it's completed outside of it. So the first thing we have to do is construct a timeline of the life cycle of each product. So we have to include a plan to recycle it and reuse the product after it's exceeded its useful life. So that starts with step 1, raw materials, to manufacturing. It kind of follows that graphic that we saw on the previous slide. Then we have to think about and document what you would change in each product design to improve impact on the environment. Then we go back to the inventory analysis and we recalculate the score based on the changes that we proposed. Then, after we've got that new score, we determine possible trade-offs that we should be considered in our product improvements. So if we change the material, does it make it more expensive? Does it make it harder to manufacture? Those kinds of things.